Hello! This is a video for Algebra 1, Chapter 4, Section 4. Today we are discussing parallel and perpendicular lines. And in case you're thinking I'm just making weird faces, I'm not. These are symbols that we use for parallel, kind of like two L's together but kind of at a slant. And a perpendicular symbol, which is basically an upside down capital T. And so to get started here, look at that. Someone just played with my board. But to get started, I want to talk a little bit first about parallel lines. Again, the symbol that we use is those double L's that are kind of at a diagonal there. And there are two things that you need to know about parallel lines. First and foremost, all vertical lines are parallel. So I have an example here in my diagram of these salmon colored lines here. And they're vertical lines, and they would be parallel to each other automatically because they're vertical lines. So all vertical lines are parallel to each other. And then if the lines are not vertical, so if there are two non-vertical lines, as long as they have the same slope right here, then they're parallel. So that's what's indicated here in the blue lines there. They are parallel as well. So that's kind of how we identify or define parallel lines. And so our first example says, write an equation in slope-intercept form for the line that passes through -3, 5 and is parallel to the graph y equals 2x minus 4. So before we even get started, at no point in time did the question actually ask me to graph anything, but I want to graph it for you so that you can see what exactly they're asking for. So the first thing I'm going to do is I'm going to graph the line y equals 2x minus 4, and using previous methods, I'm going to plot the y-intercept first, which is -4. So 1, 2, 3, -4 right here. And since my slope in this case is 2, I'm going to use my slope rise over run. So I'm going to go up 2 units and right 1, up 2 units, right 1, and I'm going to connect my points together like so. And this is y equals 2x minus 4. The other information that they gave us is the point -3, 5. So -3, 5 is 1, 2, 3, -3, and then 5 is going to be, this is 4 right about up here. This is going to be the point -3, 5. So in case you didn't know what was going on here, -3, 5 is not on the blue line at all. So they want me to write an equation that is going to pass through this point, but at the same time is going to be parallel to this line. So let me just tell you that any line that kind of has the same slope of 2, so this ruler here, that would be parallel, 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 parallel. All these lines would be parallel. But they wouldn't pass through this point. So what we're looking for is not only a line that is parallel, but it has to pass through this point. So basically we're looking for a line that's going to go through this point, like something like that, and have the same slope as the blue line. That's what we're looking for. So how we do that, we already know how to write equations in slope-intercept form. We have to have a point and we have to have the slope. Well, lucky for us we do, because we just learned in the previous slide that for two lines to be parallel, they have to have the same slope. So if the slope of this line is 2, that means that the slope of my new line also has to be 2. So I know that the point is -3, 5, and that the slope is 2. And using my point slope formula, I can say, label this x1, y1, and I can go y minus y1 equals m times x minus x1. And that'll become a plus 3 because minus negative, and then when I distribute, it'll be 2x plus 6. And then we'll add 5 to both sides, and eventually we'll get y equals 2x plus 11. And this is an equation in slope-intercept form that passes through the point -3, 5 and is parallel to 2x minus 4. So we don't have enough space to graph all the way up to 11, but you can see that they both have the same slope of 2, but they have different y-intercepts. And that's how you do example 1. So now you can try, do it yourself, number 1, and then we will move on to perpendicular. So perpendicular lines, This symbol again, upside down, capital T. And in the parallel case, we said that all vertical lines are parallel. But for the perpendicular situation, all vertical lines are perpendicular to horizontal lines and vice versa. So what I have here in the pink is basically a vertical line and a horizontal line. And any horizontal line and any vertical line are going to be perpendicular to each other automatically. And then, of course, if they're not vertical lines, then the product of their slopes needs to equal -1. If that happens, then they're perpendicular. So we've got the blue lines here. And of course, the little symbol that indicates a 90-degree angle there. Wanted to come back to this here. The technical definition for perpendicular is that the product of the slopes is -1. Another way of saying that is negative reciprocal. Reciprocal means to flip a number over, so the reciprocal of 2 would equal 1/2. Excuse me. And then that's the reciprocal portion. It would mean to flip it over. But negative means that you want to make it the opposite sign. So if the original slope was 2, then the perpendicular slope would be -1/2, the negative reciprocal. Another way that we say that sometimes is flip it. So flip over the number and then change the sign. So again, if you had a slope that was -2/3, the perpendicular slope would be for you to flip over the fraction, so 3/2, and then you would have to make it the opposite sign. So if this is negative, this one will be positive, and vice versa. You should never have two slopes that have the same sign, like positive and positive, or negative, when they're perpendicular. Perpendicular requires that they have opposite signs and that it's flipped over. So that's perpendicular for you. And so the first example here we have is the outline of a company's new logo, which by the way I think is really ugly, but that's their new logo. I don't know who would want to wear that on their t-shirt, but anywho, it's shown here in the coordinate plane, and they're asking us, is the angle DFE a right angle in the logo? And if you don't remember any geometry from before, first thing we have to do is identify what angle are we talking about, angle DFE. So what you want to do is trace the letters. The middle letter is always the vertex, so here's D, F, E. So we're talking about this angle right here. Okay, this guy right here, is that 90 degrees? Well, the only way to know that is to find out their slopes, and based on the slopes to see if the product of the slopes is -1. Because if they're perpendicular, that's 90 degrees, then the product of their slopes will be -1. That's what I'm going to do. So the first thing I need to do is find the slope of this segment, which is basically AD, and then I'm going to find the slope of this segment, which is BE, and then I'm going to multiply the two slopes together to see if I get -1. So for point A, before we get started, we have to have the points. So for point A, that's going to be 1, 2, and then Y is 1. So we're going to have 2, 1. And then for point D, we're going to have 1, 2, 3, looks like 4, and 1, 2, 3, 4, 5, 6. So I think that's 4, 6. And then we're going to go to point B, and B is going to be 1, 2, and then 1, 2, 3. And E is going to be 7, 1. All right? So what I'm going to do is I'm going to calculate the slope, x1, y1, x2, y2. So this slope is going to be 6 minus 1 over 4 minus 2. And 6 minus 1 is 5. 4 minus 2 is 2, so I get 5/2. And then over here I'm going to do the same thing, x1, y1, x2, y2. And I'm going to get my slope to be 1 minus 3 over 7 minus 2. And 1 minus 3 is -2, and 7 minus 2 is 5. So when I multiply the two slopes together, if I take 5/2 and times it by -2/5, then I do in fact get -1. Therefore, yes, that angle is a right angle. So in part B it says, is each pair of opposite sides parallel? So we have two pairs of opposite sides. We have the AC, there's one side, and EG, so we've got a pair of opposite sides there, and a pair of opposite sides there. And this time, we're looking to see if the slopes are the same. So we're going to start with point A again, because we need point A, but we also need point C. And point C is going to be 2, 6. And then we also need EG. So we need E, which is 7, 1. And we need G, which is 7, 6. Okay, so that's first pair. And we have to do this again because we have to also do CG and AE. Like, oh my goodness. C, oops, let me see here. C, what was C again? 2, 6. And G was 7, 6. And then we want, so that's CG, we want AE. Where's AE? A was 2, 1. And E was 7, 1. Okay. Hey, why can't I see my... This is not good. Sorry. Something weird just happened there. Okay. I don't know how that happened. But we need to, here we go. My bad. Okay, so here we go. So basically all we're going to do is calculate the slope 4 times and compare them. So here we go. This is going to be so much fun. So we're going to go 6 minus 1, y2 minus y1, and then 2 minus 2. So we're going to get 6 minus 1 is 5, divided by 0. So this slope is undefined. When you have an undefined slope, that means that the line is vertical, which of course we can tell from the diagram that it's vertical. And then over here in this case, we do the same thing. We're going to go 6 minus 1 over 7 minus 7, and that's 5 over 0 again, undefined, and it's vertical. And we know from before that 2 vertical lines are always parallel. So in this pair, the answer is yes, they're parallel. And then we go to this guy and we do it again. And we're going to do 6 minus 6 over 7 minus 2. And we get 0 over 5, which equals 0. And in the last pair, we get 1 minus 1 over 7 minus 2, which is 0 over 5, which again is 0. And so anytime you have a 0 slope, that means that the line is horizontal. All right, so because both of the lines have a 0 slope, they're the same slope, so they're non-vertical lines, but as long as they have the same slope, which in this case they do, they both have a 0 slope, then they're also parallel. So yes, for both of those opposite sides, then the pair of opposite sides is parallel. All right, so now in the do-it-yourself number 2, you have some points here, some QR and ST, and they're basically asking you if these 2 beams are perpendicular, so you can calculate some slopes and compare them to see if, or multiply their products to see if they're in fact perpendicular. All right, so then we have example 3. Determine whether the graphs of y equals 5, x equals 3, and y equals negative 2x plus 1 are parallel, perpendicular, and explain. Well, the first thing I'm going to remind you of is back in 3.3, we learned that any equation that is y equals, this equation right here is y equals 0x plus 5 in slope-intercept form. So basically my slope is 0, and I just said a little while ago that if you have a 0 slope, the line is automatically horizontal. And the equation of a vertical line is x equals 3. So we know that any vertical and horizontal line are going to be perpendicular. So we know that y equals 5 is perpendicular to x equals 3 because they're horizontal and vertical. And then when we think about y equals negative 2x plus 1, since the first line has a slope of 0 and this line has a slope of negative 2x, they are not parallel, they don't have the same slope, and they're not perpendicular because they're not negative reciprocals of each other, so they're not anything. The same is true for x equals 3 in this guy. So the only relationship that we can see here is that the horizontal line and the vertical line are perpendicular. As far as negative 2x plus 1, there's nothing there relationship-wise for the lines. So in do-it-yourself number 3, you want to determine whether the graphs of 6x minus 2y equals negative 2, y equals 3x minus 4, and y equals 4 are parallel or perpendicular, and explain. So basically the easiest thing, I'm just going to give you a little hint. If you take this guy, which is in standard form, and if you write it in slope-intercept form first, then you have an easier time comparing the slopes there. All right, so then we go to our last example. Very similar to example 1, only this time they want us to find an equation that is perpendicular. Our first example was one that was parallel. And you can see here that the line that they gave me is 2x plus 3. This is standard form. And as I was just saying a little while ago, it's a lot easier to identify the slope when the line is in slope-intercept form. So the first thing I want to do is transform this equation into y equals mx plus b. So I get 3y equals negative 2x plus 12, divide by 3, and then y equals, excuse me, negative 2/3 x plus 4. Now when I have it in slope-intercept form, it's very easy for me to tell that the slope is negative 2/3. Okay? And like the first example, they want me to find the equation of a line that is perpendicular to that one. So the slope that I need to use needs to be the negative reciprocal of that line. And since that line is negative 2/3, I have to flip it over and make sure that it's opposite sign. If that one's negative, this one should be positive. So my slope is going to be 3/2. And then of course, I'm going to use the point negative 4, 6. And then I'm going to use my point slope formula, which is y minus y1. So this is my x1, y1, equals my slope times x minus negative 4. And since they want it in slope-intercept form, I'm going to go ahead and simplify this. Y minus 6 equals 3/2 times x plus 4, because negative and negative make positive. Then I'm going to distribute the 3/2 and get 3 times 4 is 12, but 12 divided by 2 is 6. And then I'm going to add 6 to both sides to get y by itself. And at the end of the day, my answer will be y equals 3/2 x plus 12. And that is how you do that. So that line, y equals 3/2 x plus 12, is perpendicular to this line and passes through the point negative 4, 6. So now you will do it yourself number 4, and once you have completed that example, you will have completed your notes for this lesson, and I will see you in class, and thanks for watching.